These are the solutions for the study guide for section tests 2.1 to 2.2. So looking at the first one, it says that the trapezoids are congruent, and that means that they have the same shape and same size. And so what we want to do is we want to find the side AB is congruent to which side? Well, if we look at AB right here, here's A to B, so we look at this other figure, and since they have the same size, we look for which side does it correspond to. And A and B correspond to Y and Z. Now, how do I know that? Well, if I look at it, see here's angle B, and it has 140 degrees. Well, I don't have that angle, but right here, this angle looks to be 140 degrees. It's an obtuse angle. It's the only obtuse angle in the drawing, so that's why I'm saying it's that angle. And here, this is a 90-degree angle, angle D is, so I believe that X is also 90 degrees, since it looks to be that way. And they told me that these are congruent. So, and over in this drawing here, angle C would be the acute angle of 40 degrees. And angle A looks like it corresponds to Y, which is also 90 degrees. So if I have AB, and that one is right in here, that means that I would say YZ is the side that it corresponds to. Now angle A corresponds to which angle? Well, here's angle A up here, and so again, all they did is they just flipped this over and they turned it around, and they ended up getting this into this location here. So if I look at C, C would correspond to W, but I need to go to A. So A is up here, so that's going to correspond to Y down over on this side. So now they want to know the sum of the angle measures of ABCD. Well, that means we just need to add up all these angles here. And so we have 90 plus 140, and then plus 40 plus another 90. So whenever I add things up, I like to maybe start with these two right here, and that's 180. And then I'll add on this 140 and 40 together to give me 180, and I see that two 180s make 360. And if we remember what we had talked about in the last few sections, when we dealt with these angle measures, and then they had us sum the angles, whenever we had a four-sided figure, we had 360 degrees. And that's because we have two triangles that can be made up out of these any kind of four-sided figure that we have. So if I drew a line from Z to X, you see how we have a triangle here and another triangle here. Two triangles, again, both triangles, all triangles, have a sum of 180 as the sum of all the interior angles. And that's what we see here. Two triangles, that makes 180 plus 180 makes the 360. Well, taking a look at the next problem, I've got to tell whether the two figures are congruent. And how do I know? Well, I know congruent figures have the same shape and size. Same shape and size is what I'm looking for. And so when I look at this one here, this one is a square. It's a special type of rectangle that has all sides that are the same. This is a rectangle, but not all the sides are the same. So look at this one right here and this one right here. 4 does not equal 5. Those do not equal. So this is no. The size, or we can actually say the shape. The shapes are not the same. And then the next one would be this one down here. And so I see that this angle right here corresponds to this angle. This angle right here corresponds to this angle, and then the right angles correspond. So we have the same angles, and we have the same size, because you see how 10 corresponds to this 10 right here. This 8 corresponds to this 8 right here. Those are the same. And the 6 right here corresponds to this 6. So we have corresponding angles that are the same, as we pointed out earlier, and we have corresponding sides. And so that means we do have the same shape and size. So this would be a yes. The figures have the same shape and size. Well, looking at this one, it says that the tops of the decks are identical. And they want to know what is the length of NP. So NP goes from this point right here up to this point. So if that's the case, I look at the two decks, and it looks as though this one, too, is going in the same direction. It's not flipped over, it's not turned compared to this one. So all I have to do is look at NP and then look over here at FE. So NP corresponds and is congruent to FE. Now, I know they're congruent because they say they're identical. And so FE is 3 feet, so that's why I put 3 feet in place of that, in place of side NP, so I know that is 3 feet. And then side AB is congruent to side CD. So AB and CD are congruent. They're exactly the same. So what is AB? Well, I don't know by looking at this figure, so I have to go over to the other figure. And JK is corresponding to AB. And that does not help me out because I don't know what JK is. Now, if I look at LM, I know this is 6 feet. And this one right here corresponds to CD. And since CD is congruent to AB, I know that CD is 6 feet and AB is 6 feet. So they're both 6 feet. So we'd say 6 feet right here. And looking at what is the perimeter of figure 2. Alright, so let's go ahead and fill in the sides. Well, JK has to be the same as LM, since CD is the same as AB, so we're going to say this is 6 feet. JR is 2 feet, so we'll put 2 feet right there. And NM corresponds to ED, so that's 2 feet as well. So all I have to do is add up those sides. So I'm going to start with this 6 right here. So 6 plus 2 plus 6 plus 2. And now I have these 3 sides left to go, so I got plus 3 plus 2, and then I've got this missing side right here, which is the same as HG, so it's 3 feet. So I got another 3 feet I need to add on, and this extra 2 feet right here. So now I'll add these numbers up. This looks like 8 and 8, and this is going to end up being, I'll add up a few more numbers here. This is 5 and 8, or 5 and 3 makes 8, and then I have to bring down this 2, so this makes 10 and 16, so it looks like it's 26 feet is the perimeter of figure 2, which would also be the perimeter of figure 1 as well. So let's take a look at the next problem. Now taking a look at number 4 here, it says translate the figure 4 units left and 1 unit down. So all I'm going to do is just take each of these vertices and do exactly what the translation says. 4 units left, 1, 2, 3, 4, and 1 unit down. And I continue working to this point here, this vertice, 4 units left, 1, 2, 3, 4, 1 unit down. Here, 4 units left, 1, 2, 3, 4, 1 unit down. And 4 units left brings me back to the origin, and 1 unit down. I'll connect these with lines, and you should see the same figure just slid over, slid to the left and then down. And so now we have to name the points. So I'll just start with this point. And this point is -4, negative, or positive 3. So -4, positive 3 is that point right there that I'm talking about. And I'll just write it right in the spot that they give me here. And I'll go over to this one. It's 1 unit to the left, and then it is 3 units up. And so that one is -1, 3. And then this point is just 3 units to the left, 0 spaces up. So -3, 0. And the last one here is 0 spaces over and 1 space down. So 0, -1. Describe the translation moving from A, B, C, D to A prime, B prime, C prime, D prime. So I'll just start from one of these points. I'll start from D here, and if I just go over to the left, 1, 2, 3, 4, 5, 6, 7. That's how many spaces I had to go over to the left. So I have to go left 7 spaces, left 7 to get to the same x value as D prime. And then I had to go down 1, 2, 3 spaces. Then down 3 spaces. Now, you could have gone down first, then left. That would be fine. It doesn't matter as long as you have left 7, down 3 describes that translation. The other way to describe it is using just some symbols. And so in the x direction, for whatever x value I have to take away 7. Down 3 means that I'm going to take 3 away from the y component to get to that point. So either of these two answers would be fine. Looking at this one here, it says find the coordinates of the vertices given this formula here. So for r, if I do for r prime, it's going to end up being -4. I'm going to start with that value. That's the x component. And then I'm going to take away 3. And then I do the same thing with the y. So -3 goes in place of the y. And I'm going to add 2. And so when I do that work, I get -7, -1. So that would be r prime. So that's one of them. And then the next one, d prime, is going to be -4, take away 3. So -4 and for x this time. And then 0 and for y plus 2. So that would be -7, 2. That would end up being d prime. And then the next one, 0, 0 for L. So L prime is 0, take away 3. And then I'm going to do 0 plus 2. And so that makes -3, 2. And that's L prime. And then the last one is going to be F prime. And that is going to be 0, take away 3. And -3 plus 2. And so that ends up giving me a point at -3, -1. And that would be F prime. So taking a look at the last 3 problems, and we have this one here. It says this is a regular hexagon, which means all sides are the same length. Well, if all sides are the same length, we can find x because we can set 5 times x plus 2 equal to 7x plus 4. You can go ahead and solve. So I'll use that distributive property, 5x plus 10 equals the 7x plus 4, and then I'll just use opposite operations. So we'll go ahead and subtract the 5x from all sides. And along with doing that, I'll go ahead and subtract the 4 from all sides to save myself a little bit of time. And so now I've got 2x equals 6. I'll divide by that 2. And when I divide 2 into 6, that gives me 3. So I know x is 3, but that's just part of the problem because they say find x and then find the perimeter. Well, the perimeter is just one of the sides, since all sides are the same. Find out one of the sides and multiply it by 6 because there are 1, 2, 3, 4, 5, 6 sides in this hexagon. And so 7 times by 3 plus 4. So it makes 21 plus 4 gives me 25. I get the same thing if I put 3 in for this x here. Then I take that 25 and I multiply it by 6, and that gives me 150. So 150 units is the perimeter. And looking at the next one, it says discounted concert tickets cost $12.50 less than the original price. You pay $50 for the discounted ticket. Write and solve an equation for the original price. So I'm going to say right here, I'm going to say that the original price is P. That equals P. So I'm going to start off with P, the original price, take away $12.50 from the original price will equal the discounted ticket of $50. So there's my equation. So I did the equation. Now I have to solve by just doing some opposite operations. So I'll go ahead and add the $12.50 to both sides, and that will give me my answer. So $62.50. That's the cost of the original price of the concert tickets. Last one here. We have to solve this equation, so I'm going to take -8 and distribute it over that subtraction. So I end up with 6 minus 32 plus 8c. Plus 8c, because notice how it's a negative times a negative makes a positive. And so from that point, I'll collect these two terms. I get -26 plus 8c equals -26. So at this stage, people are going to end up thinking, oh, maybe it's a no solution or infinitely many solutions. Because when we add 26 to both sides, I get this situation. But that's not. This only has one solution. And the one solution is what c is when I multiply it by 8 to make 0. and the only number it could be would be 0. And so 0 can be an answer. It doesn't mean there's no solution or infinitely many. It's just one solution of 0. And you can see it works, because if I go ahead and plug that in, 4 minus 0 makes 4. And when I multiply the negative 8 by 4, I end up with a negative 32. When I take the 32 from 6, I get negative 26. And those two numbers do equal, so it does check out. So those are the problems that we'll see on the test. Good luck.